All right, part two, and I think we've got about 6 or 7 parts in this one. Uh, Different types of relationships that we might observe. We'll first start looking graphically at stuff, and then we'll get into some statistical, some numeric ways to represent these relationships in a sec. So one thing we'll see when we're talking about correlations is that we're talking about the relationship between two variables, what's called bivariate statistic. The main types that we'll talk about are the Pearson's correlation coefficient, probably the biggest one, and then the Spearman's correlation coefficient. We'll see that these are for different types of data, and I'll talk about that in the next section, I believe. One thing that we assume here is that we assume a linear relationship, and what that means is that we're looking at situations where as one variable rises, the other one rises, or the other one falls, or nothing happens, rather than situations where we might see a curved relationship, where you might have, for up to the middle of the scores, a relationship where we rise and then it falls off. Those sorts of things aren't appropriate. We'll see that we can readily see when we have that situation graphically. So here's a graph. This is education and salary. One thing you can see, and I'm sure that's why a lot of people are in college classrooms, is that as people attain more years of education, their salaries tend to rise. You tend to have higher salaries. That doesn't mean that there are not high school dropouts who have very high, who make a great deal of money. It doesn't mean that there are PhDs who have very low paying jobs. But in general, there's a relationship here. Well, this is what we would call a positive relationship. As one variable goes up, the other one also goes up. And we see that as, the scores kind of moving upwards together. You can see that with the line. When we have what we call a positive relationship, we would have a line that's going upward. Okay, this is from some of the research from my research lab, where we examine intergroup friendships, that is friendships with people from other ethnicities, and negative attitudes in this case. We measure a lot of stuff. This is just one of negative attitudes. What we see is that in general, when you have more friendships with people from other ethnicities, your attitudes toward that group tend to improve, or in this case, get less negative. So you can see that's evidenced by a line that's going downward. That line that's going downward signals what we call a negative relationship. Now, positive and negative here aren't value judgments. They just indicate the direction of the relationship. Had I measured positive attitudes here, we would probably have a positive relationship, because friendship would improve those positive attitudes, reduce the negative ones. Here's age and job seniority. Two things that would normally go together. The people who are older tend to have worked at a place longer. However, this is at a brand new company. And this is the third type of relationship that we might see. What's basically no relationship. When it's a new organization, age that isn't related to how long somebody has been at the organization yet. So we would see practically a flat line in a situation like this. Here is a graph that shows a relationship, a hypothetical relationship that is non-linear. It's not appropriate for correlation techniques. What we see here is that as education is rising, there seems to be a jump in HIV risk during the college years, but as education goes further down, there seems to be a drop-off. Perhaps nobody wants to have sex with grad students. I don't know. But you see that it's basically a positive relationship for the first 2/3 of the graph, and then a negative relationship for the last piece. You could try to fit a straight line to that, but that wouldn't really describe the relationship very well. A relationship like this would be better explained by a curved line. There are statistical procedures for doing this. They're beyond the scope of this class, but one of the reasons why we use graphs is to verify that we have something that could reasonably be explained by a straight line. If we have this sort of relationship, all of our correlation statistics aren't going to help us because they're not going to be informative.